Hello guys, this is Bisola from Zip Automations. So I'll be showing you guys a quick demonstration of this process control trainer using the PID control programming. Well, the basic idea behind the PID controller is to read a sensor and then compute the desired actuator output by calculating the proportional, the integral, and derivative responses, and summing those three components to compute the output. So in my lab here, I have a Siemens 317 PLC, and I have a 2 horsepower Delta VFD, a 3-phase pump, a Vega Sin 61 ultrasonic level meter, and we'll be using a PID control program to demonstrate a liquid level control system. The programming software for this is Schematic Step 7, and this is my PID block. And I'll be using Schematic WinCC for my human machine interface. For my human machine interface, I'll be using Schematic WinCC. This design was quickly put together just for this demonstration. So in my liquid level system, I have 2 tanks, and the tank 2 level is our main target. That's what we are trying to control. So now how this works is I have liquid from tank 1 pouring into tank 2, and as you can see, I have a level meter on tank 2, and there's a pump down here that drains the liquid in tank 2 back to tank 1. Now up here I have a valve, a discharge valve, that causes a disturbance in the system so that the liquid level in tank 2 varies above and below the set point. The VFD that controls the pump is a control variable, and the liquid level in tank 2 is a process variable, and I have my error, which is the difference between my set point and my process variable. Now I have my proportional gain, and I can set that to be minus 0.1. 0.1. And I already have my integral gain set to 20,000, and I won't be imputing anything for my derivative gain because the system is a PI controller, and I have my set point set to 50%. Now from my tank 2, you can see that I have my liquid level, the maximum liquid level, to be 70 centimeters. And this is in percentage. So if I'm saying I want my set point to be 50%, that means I want my set point to be 50% of this maximum value, which is 70. So I have my set point to be 35, and I have my output high limit to be 100. I set that to 100, and I have my output low limit in percentage to be 0. Now I have my trend view here, or my graph, whichever way, and from the symbols here, I have the red line, which represents my process variable, which is the liquid level in tank 2, which is what we are trying to manipulate. And I have my control variable, which is my VFD, and I have that as this blue line. And I have my set point, which is 35, as I imputed to be this yellow line. So let me quickly take you guys through my PID block. As you can see here, I have my set point to be MD122. I have my process variable, which is the liquid level in tank 2, and I have my manual, I have my gain, my proportional gain. All these are tagged to my HMI. That's why I'm able to impute values straight from my HMI design. Okay, now currently it's on manual, so my PID block won't work. And currently the liquid level in tank 2 is above my set point. Remember I said my set point is 35. Is above my set point. It's currently 50.9. So what I expect is when I switch this to automatic, I expect my control variable, which is my VFD, to ramp up such that the process variable, which is the liquid level in tank 2, can reduce or come close to the set point as much as possible. So when I go to automatic, let's see, I should have my control variable ramping up. That's the speed of my VFD increasing so that it can drain the liquid in tank 2. So let me start my pump and take this to automatic. So let's see how this works. Now let's see. You can see the control variable, which is my VFD, is adjusting so that my process variable can come close to the set point as much as possible. Now you can see the control variable is ramping up, going to 100%, and then you can see our process variable has started adjusting, trying to come close to our set point, which is 35 centimeters. And I still have my control variable, which is my VFD, trying to adjust. And okay, this is trying to come close, but not yet at 35. So I have my VFD trying to adjust until this comes close to the set point. Okay, the 42. Now the error is reducing. The error is reducing because the process variable is coming closer to the set point than it was before. So, okay, now we can see our process variable rather, is now below our set point. Now we should see the control variable again trying to adjust, trying to go or bring the pump back to 0. And you can see that it's trying to bring the pump back to 0, and have my process variable again trying to come or adjust back to my set point, which is 50. You can see that from the graph or from my trend view. And okay, this should go down to 0, and this process variable, which is my liquid level, is coming closer to the set point, which is this yellow line here. So guys, that will be all for now, but for more inquiries you can visit our website at www.zipautomations.com, or you can send us a mail at zipautomations@gmail.com, or you can reach us on 081-366-84493 or 070-8979-5434. Thank you. Bye.